So this is another type of question that shows up in section 3.2. If it's fall 2002 and you have COWL for your instructor, then I believe this is question number 3 in 3.2. So they give you the output here that is just like what you would get if you, in the other questions, when you use the TI-84, and it gives you the mean, and then here is the sample standard deviation, and then just below it is the population standard deviation. And the question starts with saying, assume the population is bell-shaped. And what that means is that if you were going to make a histogram of it, it would look something like this. This I drew, it's far from perfect, but what I'm going to have you do for all of these types of problems is to draw your own bell-shaped curve like that. And what that means is that the most of whatever it is that they're measuring, most fall in the middle. As you get farther away from the middle to either side, lower numbers or higher numbers, it drops off and it ends up with this curve that looks a little bit like a bell. So if the population is bell-shaped, then there's some specific things that you can assume about it. And so the easiest way to come up with the answers for this, once you've drawn this, then you're going to draw a line down the center, and that line represents your mean or your average, which in this case is 160. And then I want you to draw 3 lines roughly evenly spaced to the left. It does not need to be anywhere near perfect. Mine aren't going to be all that great. Okay, so we've got now the mean in the center, 3 lines to the left. Now draw 3 lines to the right similarly. And then, then we're going to fill in values for each of these lines for where they trying to get this to move a little bit. Okay, never mind. So now we're going to draw in what values correspond to these different lines down here. So we know that the mean is 160, so that is the line that you drew straight down the middle from the highest point. So we're going to label that here as 160. And then the standard deviation, whether it's population or sample, tells you how spread out the data is, so how far from the mean most of the data is. Since they refer to this as the population, we're going to use the population standard deviation of 5. And what these lines here represent is 1, 2, and 3 standard deviations above the mean and below the mean. And so what that means is to figure out what number corresponds to each of these lines. This one is 160 plus the standard deviation, which is 5, so it's 165. So on your paper, scrap paper, where you're doing this, you're going to write in all of these numbers. So 165, and then you're going to go up. The next one goes up another standard deviation, or in this case another 5, so that one's 170, and then this last one is 175. So it just keeps following that pattern. And then it does the same thing to the left, except that you're subtracting because those numbers are below the mean. And so this one would be 155. This one would be 150. And then one more down the last line to the left is 145. Okay, so important thing to note here, the reason I was adding and subtracting 5 from the mean is because that was the population standard deviation. So in different problems, you'll have a different number here, and you'll add and subtract whatever that number is. It's not necessarily going to be 5, it could be anything. Okay, so it makes all of the other questions quite a bit easier. So this says approximately blank of the population values fall between 145 and 175. Whatever numbers they give you here are always going to be numbers that you've just found. And so, and then there's rules that go along with it depending on which lines those numbers correspond to. So in this case, its population values fall between 145 and 175. That is between the leftmost line that we drew and the rightmost line that we drew. Those lines always correspond to all or almost all is how they write it in there. So I'm going to make these little double-sided arrows. So if it goes from this line all the way out to this line, then that is all or almost all of the population. When you do this drop down, you're going to have the choice of all or almost all, 95%, and 68%. If they had given us the numbers 150 to 170, if it was going from the second to leftmost over to the second to rightmost line, then it would be, draw that up here, and the arrows on it, and this one goes a little bit farther out here. So if it was 150 to 170, that would be 95% of the data would be the answer to that one. 95%, meaning that 95% of the people that answered this survey or whatever it was we were doing, 95% of them fall into this range between 150 and 170. And then the last group of numbers you could have are the ones that would go from here to here, roughly, more centered, okay, there to there. And if it was going, in this case, from 155 to 165, they were asking about those, then that would correspond to 68% of the data. And so put that one up here. So you will either be given numbers that correspond to your lowest and highest line, your second lowest and second highest line, or your third lowest and third highest line. And so your answer is either going to be all or almost all, 95% or 68%, depending on which set of numbers they give you. For the second part of this one, they're turning it around and they're saying maybe they're giving you one of these percents, either the all or almost all, 95% or 68%. So if they asked you what population values correspond to 68%, then your answer would be in there. They've got two blanks for you, and then you just read down the numbers that you figured out here. So in this case, it would be 155 to 165 would be your answer. The last one gives you a example where it's not bell-shaped, and I believe the example of that I saw, it gave 150 and 170, so that would normally be 95%. In that case, if it's not bell-shaped instead of 95%, then it's 75%. You might need to, in that one, check on the show example, and it should give you a table of how that corresponds. That if it was bell-shaped, it was 95%. Then if it's not bell-shaped, it's some other percent. So check in the show example to see what those would be for your particular numbers.